Good day everyone, here's our math challenge for today. And the question goes like this. Solve for the real value of x given that ln of x raised to x equals ln of x squared. You can pause this video if you want to give this problem a try. Now let's answer this question together. So given that ln of x raised to x equals ln of x squared, and we want to find the real value of the variable x. Now the question is, how do we start our solution? Now take note that ln of a raised to n can be written as ln of a quantity raised to n. Therefore, this ln of x raised to x can be written as ln of x raised to the power of x. Also, this ln of x squared can be written as ln of x raised to the power of 2. Now, what we're going to do here is to equate this to 0. So let's subtract ln of x squared on both sides. Now, in this equation, I like to factor out ln of x quantity squared. But the problem is ln of x raised to x don't have a factor of ln of x quantity squared. So what we're going to do is to multiply this ln of x raised to x into ln of x squared over ln of x quantity squared. Take note that ln of x squared over ln of x squared is just 1. Now, since both terms have a factor of ln of x quantity squared, we can now factor out ln of x quantity squared. So this will give us ln of x quantity squared multiplied by ln of x raised to x over ln of x squared minus 1. Now, looking at this expression, ln of x raised to x over ln of x raised to 2, this reminds me of a law of exponent that says that if we have the same base, b raised to n over b raised to m, this can be written as b raised to n minus m. Therefore, this expression can be written as ln of x raised to x minus 2. Now, since it is equal to 0, it follows that at least one of them must be equal to 0. So we can say that ln of x quantity squared equals to 0, or ln of x raised to x minus 2 minus 1 equals 0. Now, on the first equation, we have ln of x squared equals to 0. Let's solve for the value of x because that's our goal. Now, let's get the square root on both sides. This will give us ln of x equals to 0. Now, this reminds me again of one identity that says that ln of 1 must be 0. Therefore, technically speaking, x must be equal to 1. So on the first equation, we get that the value of x must be equal to 1. Now, how about on the second equation? Let's add 1 on both sides. So to have ln of x raised to x minus 2 equals 1. Now, since this expression ln of x raised to x minus 2 equals 1, we have two possible cases here. The first one is the exponent of ln of x must be 0 because any number raised to 0 is just 1, provided that the base is not equal to 0. So in this case, we can say that x minus 2, to make it equal to 1, this x minus 2, the exponent of ln of x, must be equal to 0. Thus, x minus 2 must be 0. If we add 2 on both sides, we get that the value of x must be equal to 2. So now we have two possible values of x. We have x equals 1 and x equals 2. Now, another case in this equation, since it is equal to 1, don't forget that it is equal to 1 if the base is also equal to 1, because 1 raised to any number is just 1. Therefore, we can check also the case that ln of x must be equal to 1, or this base must be equal to 1. Now, at this point, take note that if we have ln of b equals a, this can be written in an exponential form as b equals e raised to the power of a. Therefore, this ln of x equals 1 can be written as x equals e raised to the power of 1. Now, e to the 1 is just e. Therefore, on the second equation, we get that x equals 2 or x equals e. Therefore, given this equation, ln of x raised to x equals ln of x squared, the value of x that satisfies this equation must be x equals 1, x equals 2, or x equals e. Now, you can check those three values and see that all those values satisfies the given equation. And as always, we are done.